So what we have now is two confirmed cases of tularemia in people in Tasmania that had a history of close contact with sick or dying ringtail possums. The question that must be answered is do we consider that ringtail possums are the principal reservoir of infection? Well, we really don't know. What we do know is that ringtail possums are common along the entire east coast of Australia, but obviously they don't move between Tasmania and mainland Australia. And we don't know of any other species that have also been affected. How long has tularemia been in Tasmania? Well, we just can't be sure. What I did find out is that ringtail possum populations have been reported to have declined over recent decades, starting in about the 1960s. They used to be the dominant possum species, and this is just no longer the case, certainly in eastern Tasmania, where the most common possum now is the brush-tailed possum. There is also a great deal of potential for undiagnosed cases of tularemia to have occurred. In the Tasmanian case, the infection went undiagnosed, even though the woman involved sought treatment. It went undiagnosed for close on 45 days, and additional culture was only undertaken, or additional investigation was only undertaken when the lesion did not respond to traditional antibiotic therapy. So, basically, many doctors in Tasmania would not have considered tularemia as a possibility prior to this event. The other factors that should be discussed are what are the possibilities of people coming into contact with ringtail possums. This species, more so than brushed-up possums, are 100% arboreal or live in trees and tend not to come down from trees and sort of scavenge on the ground like brushtails do. They are also a nocturnal species, and therefore the combination of being arboreal and nocturnal would suggest that they're unlikely to come into contact with ground-dwelling species or humans. Also, as I've tried to describe earlier, the Central West area is an isolated region. It doesn't have a huge human population, and there has not been a lot of land clearing going on in that area, unlike many other parts of the world. The region really relies on fishing, aquaculture, and mining, and therefore basically the ecosystem hasn't been disrupted and possums pushed out. But as I say, in both cases, people came into contact with these sick possums because they are outside of their normal environment. And the recent development or relatively recent development of people concerned about sick and injured wildlife, and I haven't confirmed whether these women were wildlife carers or careers. Sorry about the spelling there. But basically, people undertaking wildlife care activities probably are putting themselves at higher risk associated with this disease. The other question that needs to be answered is how did tularemia get to Tasmania and now that we, in addition to the east coast of Australia? There are probably a number of theories that have been proposed, but there is really no evidence to confirm what they are. One theory is that the bacteria came here in migratory birds, and certainly when I looked into what birds were migrating to Tasmania, these three species here, the godwit, the tern, and the stint, would be possible candidates because they do migrate from infected regions in Europe to Tasmania. So that is a possibility. The other possibility is that the bacteria was imported with things like rabbits, hares, or rodents that came to Australia. But you would have to ask, why has it not been detected in other areas where people come into much closer contact on a more regular basis with such animals? Or is it just that it's a localized infection on the west coast? But again, we have the issue of the infection in Sydney, so therefore we have two areas of Australia where infection has occurred. The final theory is that it's always been here and nobody's detected it, but again, why has it taken so long for this detection to occur? So the second case I wanted to discuss is abalone viral ganglioneuritis, and this is something I'm quite familiar with, and it's something I've dealt with for a number of years here in Tasmania, and it's caused by a novel herpes virus that affects abalone species, or the Haliotis species. AVG, as we commonly refer to it, was first detected in Taiwan on abalone farms in 2003, and then the first detection in Australia actually occurred in Victoria in 2005. That was also on farms. Basically, the virus then spread from the infected farm in Victoria to wild abalone populations adjacent to this farm, caused significant mortalities along the Victorian coast during 2006. And in the paper that was circulated with the reading material, this is largely what has been reported by Lafferty. But really, this is only half the story. What we do know about the Victorian event is that the disease on farms was associated with translocation of wild abalone for use as broodstock on the farms. And when the disease emerged, basically it was suggestive of new disease incursion because of the very large level of mortalities, the apparent lack of immunity in any of the affected populations, where it basically wiped out the populations involved, and the spread from a point source in the Victorian fisheries. AVG was also later detected in New South Wales and WA, and these detections were within sort of live holding facilities that were carrying wild-caught abalone. There was also a separate review of viral diseases undertaken by the OIE, and the expert panel that looked into the viral diseases of abalone suggested that there were a number of Chinese cases that appeared to be similar to AVG, and that these may be linked to outbreaks of disease in Taiwan and could well be the same thing. So, talking about this disease in Tasmania, this was actually first detected in 2008 in a live holding facility that kept wild-caught abalone. And the thing with Tasmanian fishery, which is one of the largest abalone fishery in the world, is that it concentrates on live product, and the principal market is live export to Asia. Now, Tasmania has never had any reports of this disease in wild populations, but we have had quite a number of outbreaks of the disease in live holding facilities for wild-caught abalone prior to being shipped to Asia. And we see the disease primarily when abalone are held for extended periods, say greater than 7 days, in these live holding facilities, or we will see it earlier if cohorts or abalone from two different regions caught in Tasmania are mixed together in these live holding tanks. Further work undertaken by the Department of Primary Industries suggests that there is a subclinical carriage of approximately 7% in abalone tested, and really basically this carriage of the disease apparently goes on without any observable or detectable signs of disease while the abalone are in the wild environment. So following all these outbreaks of disease in wild abalone live holding facilities, the department worked with AAL, the Australian Animal Health Laboratories in Geelong, to genetically type the various isolates and found that there were 5 different isolates identified from Tasmania, or strains identified from Tasmania, and obviously this added to the Victorian strain, and also the Taiwanese strain made a total of 7 known strains of AVG. It's important to know that mollusk immunity is not based on an acquired immunity. It's primarily a cellular response, and therefore any acquired immunity any development of immunity tends to be evolutionary. And mollusks such as Abalone are sedentary species, and because of this, they're not very mobile and form distinct subpopulations wherever they go. And the theory is that AVG has actually evolved with these subpopulations of mollusks present in Tasmania, and effectively the two are linked within the actual natural environment. So this map shows the geographic location of where we have picked up different strains of AVG, and where the life holding facilities in the square symbols show the processes where they were actually identified. Because of the quota system in Tasmania, we can actually identify which part of Tasmania these infected abalone come from, and trace them back to their origins. And this is what this diagram is trying to represent, that each of the different strains has actually a distinct region in which it originates, and a principal area for, say, things like Tas 5 is King Island, whereas Tas 1 has only been located in the southern part of Tasmania in blacklet populations down there. So what does all this mean? Another hypothesis that's actually been put forward is that it may not actually be the virus that's causing the damage in individual abalone, but it actually may instead be an overactive immune response or cellular immune response within affected abalone. And this has a precedence overseas, where in islands off California, the disease withering syndrome, which is caused by a rickettsia, that wiped out large numbers of abalone on islands, and when they went back to look at the remnant populations, they found that the pathogen was still there. It's just that the abalone were tolerating it and not responding to it, rather than dying and becoming infected. So we saw something similar in Tasmania with AVG, whereas the diagram, or the picture A here, shows a very florid cellular response in one group of abalone detected in a tank. Within the same group, same tank, a separate group of abalone from a different region of Tasmania had a much lower response. In fact, the picture in B would have been classified as normal by our pathologist here in Tasmania. Ironically, when they were tested using PCR, the animal in A had a fairly high CT value, or a low level of virus, whereas the animal in B had a very low CT value and yet had no response to the presence of this high level of virus. So in summing up, basically, what do we know about tularemia in Tasmania? The detection in people in Tasmania, and also within possums in the east coast of Australia, including Tasmania, clearly represents an extension of range. It also is the documented infection in ringtail possums also is an increase in the number of susceptible hosts. What we do know is that the natural habits of ringtail possums do restrict contact with people, and therefore that may have played a factor in why tularemia cases have not become obvious until now. In Tasmania, certainly, the environment on the west coast means that there is not a lot of clearing, and the environment that possums naturally live in is still present in quite a large area, and people tend not to go into these areas because of the thick vegetation. Control measures for tularemia are really based around hygiene measures for people handling infected animals or potentially infected animals, in the same way that people are advised for handling potentially infected bats and such. So those people need to be educated in protecting themselves using adequate gloves and being aware of the risks. At this stage, we don't know whether there's any invertebrate vectors involved in the spread of tularemia. This may be a factor in the possum populations, but neither of the cases in Tasmania were associated with insect bites. Both were associated with bites and scratches from infected possums. In the case of AVG, this also represents an extension of range. It is now considered that AVG is actually endemic in Tasmanian abalone and has always been. So the outbreaks in Victoria represent the extension of range, with the movement of wild abalone onto farms for use as broodstock. And as I say, the transfer mechanism is movement of the live host or subclinically infected live host, and this can potentially have spread the virus interstate to Victoria, but certainly within Tasmania as well, and potentially it may have spread the virus overseas to China with live exported product, and even to Taiwan. We do know that Tasmanian abalone, because they are exported live, have great potential to be used as broodstock in China as well, and Taiwan, and we just don't know what's occurring. The important thing here is that mollusk evolutionary immunity means that the population genetics within mollusks develop in conjunction with the virus, and therefore the immunity to the disease is quite specific, and movement or mixing of resistant abalone that may be infected into naive populations rapidly causes expressions of clinical disease. In Tasmania, the main control mechanisms for this disease have been that processors need to now maintain adequate treatment of their discharge water, so that if they are taking abalone from out of region, that any development of disease is not spread to the adjacent marine environment and is kept within the process boundary of the process itself. So, okay.